Hey guys, it's Miss Adams again, and we're looking at lesson 6B.4, solving quadratics by square roots. So the learning target for the day is to figure out how we can solve quadratics in both vertex form and standard form using the square root method. So in Unit 6A, we learned how to solve quadratic equations by factoring. That was when we converted from standard to intercept form, and we set those intercepts to 0 to find our x-intercepts. Today we're going to talk about solving by the square root method. And then later in Unit 6B, we're going to talk about the quadratic formula. And we're going to talk about completing the square. Alright, so let's talk about the square root method. So it says solving a quadratic equation by the square root method is used, 1, when the equation is written in vertex form, or 2, when the equation is written in standard form, and it does not have a linear term, which means it does not have our b term. So it's just ax squared plus c, no b term. Here's the steps that we're going to follow to solve using the square root method. Step 1 is to solve. We're going to substitute y, or f of x, to 0. So just like we did when we were solving from intercept form, we're going to set that y value to 0 to solve for our x-intercepts. All right, we're going to isolate the square. So either get x squared or our parentheses squared by itself on one side. Then we're going to take the square root of both sides. Remember to put the plus or minus on the right side. So just like we did in the warm-up where we knew that 6 squared was 36 and negative 6 squared was 36, that square root of 36 gave us a positive and negative 6 value. That's what we're going to be looking at here. And the last thing we want to do is isolate the x. So let's go on down to example 1. This tells us y equals x squared minus 25. First off, this is in standard form. We're just missing that linear term, so we're missing that b of x term. Let's go ahead and identify our y-intercept from this. So, if I were to set x equal to 0, our y-intercept is just our c value, which is negative 25. Now, let's go into this, how to actually solve using the square root method. First thing to do is to set our y value equal to 0. So I have 0 equals x squared minus 25. Then we want to isolate our x squared. So in this case, we want to isolate this x squared term here. In order to do that, we're going to add 25 to both sides. So I have 25 equals x squared. Then we're going to take the square root of both sides. So I have the square root of 25 is equal to the square root of x squared. That's going to tell us that x is equal to plus or minus the square root of 25. But the square root of 25 simplifies to 5 because that's a perfect square. So in this case, x is going to equal plus or minus 5. So those are our solutions. X equals plus or minus 5. And I can write that out as x equals a positive 5 and x equals a negative 5. Just to show that there are two solutions there. Now, it asks us if it's rational or irrational. This is an integer. It's a whole number integer, so therefore it is rational. And our x-intercepts in this case are going to be positive 5, 0 and negative 5, 0. Going to the right to look at the u-try problem, we always have to remember we're trying to isolate our x squared term. So we follow the same first step. We set that y value equal to 0. So we have 0 equals 4x squared minus 16. Then I'm going to add a 16 to both sides. But looking at this, I'm going to flip it a little bit. So I've got 16 equals 4x squared. Let's flip it so our x squared is on the left-hand side just to make it a little bit easier to see. Our x squared term is not isolated at this point. We still have it multiplied by 4 right now. So we're going to divide both sides by 4. So that leaves me with x squared equals 4. Just going to move that there. Now we're to the point, we're on step 3 where we can take the square root of both sides. So I'm going to find the square root of x squared and the square root of 4. That's going to tell me that x equals plus or minus the square root of 4. And 4 is a perfect square, so x equals plus or minus 2. Alright, so if we're answering the questions at the bottom, we were originally given standard form, so our y-intercept's just our c value, which is going to be 0, negative 16. Now, if I'm looking for my roots, in this case, that's what we just solved for, because our solutions, our roots, our x values, those are the same thing. So that was where x was equal to plus or minus 2. And because 2 is a whole number integer, it is rational, and our x-intercepts in this case are positive 2, 0, and negative 2, 0. Let's move on to example 2. Now, example 2 is given to us in vertex form. So at the bottom, the first thing it asks us to identify is the vertex. Well, I know it's negative hk. In this case, our h value is negative 8, so I'm going to switch the sign to a positive 8. And then our k value is negative 45. So just like we did with standard form, we're going to try to isolate our squared term. But in this case, our squared term is actually our parentheses. So we're going to try to isolate that parentheses. First thing I do is set our f of x equal to 0. So I have 0 equals 5 times x minus 8 squared minus 45. And I'm going to add 45 to both sides. That's going to give me that 45 equals 5 times x minus 8 squared. Then I'm going to divide both sides by 5. And that gives me that 9 equals x minus 8 squared. At this point, we have isolated our squared value here, our squared expression. So we then move on to our step 3. So if we're looking at our steps, we're going to take the square root of both sides. So I'm going to do the square root of 9 and the square root of this x minus 8 squared. So I'm going to move over to our right-hand side here. And I'm going to have the x minus 8 is equal to plus or minus the square root of 9. 9 is a perfect squared, so I can rewrite this as x minus 8 equals plus or minus 3. At this point, our x is not by itself. We have not solved for the variable x, so I have to split this into 2 equations. I'm going to have x minus 8 equals a positive 3, and x minus 8 equals a negative 3. So I've just broken up this plus or minus sign. Then I'm going to solve these like I would a one-step equation. I'm going to add 8 to both sides for our first equation. So that's going to give me the value of x equals 11 as our first solution. I'm going to do the same thing on our second equation. I'm going to add 8 to both sides. And that gives us the value of x equals 5 as our second solution. So our roots in this case are x equals 5 and x equals 11. Both of these are positive integers, so they are rational. And our x-intercepts are at 5, 0 and 11, 0. So let's look at this U-try. Looking at this first, we know it's in vertex form, so let's write out our vertex. Our negative h in this case is going to be negative 2. So we take whatever's inside the parentheses and change the sign. And our k value is negative 16. So our vertex is at negative 2, negative 16. And now we're going to solve using the square root method. So I have 0 is equal to 4 times x plus 2 squared minus 16. First thing I want to do is add 16 to both sides. So I have 16 equals 4 multiplied by x plus 2 squared. And I want to isolate this x plus 2 squared, so I need to divide both sides by 4. So I'm left with 4 equals x plus 2 squared. At this point, we're on to step 3 of solving by the square root method, which is taking the square root of both sides. So I'm going to take the square root of 4, and that's going to be equal to the square root of x plus 2 squared. So if I rewrite that, I have x plus 2 equals plus or minus the square root of 4. So that when I take the square root, that square just comes off of that expression, that squared expression. So now I've got to break this up after I simplify the square root of 4. That simplifies to 2 because it's a perfect square. So I have x plus 2 equals plus or minus 2. And then we break this into 2 equations. So I have x plus 2 equals a positive 2. And x plus 2 equals negative 2. Then we do our final step, which is solving for x. I'm going to subtract 2 from each equation. So in our first equation, 2 minus 2 is going to give me 0. So one of my solutions is x equals 0. On the second equation, I have negative 2 minus 2. That's going to give us an x value at negative 4. So my zeros in this case are x equals 0 and x equals negative 4. Both of these are integers, so they can be written as fractions or as ratios, so they are rational. And our x-intercepts are at 0, 0, so the origin, and negative 4, 0. All right, we will look at example 3 and example 4 in the next video.